Hello guys, welcome back. Today we are going to understand today Leetcode question, and today we have 2141 Leetcode question in which we have to find the maximum, right? And we'll see how to find the maximum running time of our n computers, right? So let's read the question and then we will go through one by one. Okay, so the question is saying that you have n computers, right? And you are given a n integer and 0 index integer, that is called array batteries, right? So you can see here we have given batteries and we have given n equal to 2 in the first example, okay, where the ith battery can run a computer for batteries of I minutes, right? And you are requested in running all n computers simultaneously using the given batteries, right? Initially you can insert at most one battery in each computer, right? Initially one battery in each computer. After that, at any integer time moment, right, you can remove a battery from a computer, insert another battery any number of times. The inserted battery can be totally a new number, or you can say battery from another computer. You may assume that the removing and inserting process will not take any time, right? Will not take time, and note the batteries cannot be recharged. Okay, another return the maximum number of minutes you can run all the n computers simultaneously, right? Means these are the computers we have given, right, as you can see in the figure, right? And then what is happening here, like 0 1 2 3, right? These are batteries we have given and these are computers we have given, right? So there is n equal to 2, right? We have given, means integer given n, right? Means n computers have. So n equal to 2 means 2 computer we have given, right? But batteries we have given 3, right? 3 3 3, right? As you can see the example 1 right here. So what is happening here? So if we are going to initially we are going to take one battery and insert in the first computer, and the battery 1 into the second computer, right? As you can see here. Then after 2 minutes we will remove battery 1 from the second computer and insert battery 2 instead, and we'll note that the battery 1 can still run for 1 minute. At the end of the third minute, battery 0 is drained, right? You need to remove it from the first computer and insert battery 1 instead. By end of the fourth minute, battery 1 is also drained, right? The first computer is no longer running. We can run the two computers simultaneously for at most 4 minutes, so we return 4. Got it? Means it is saying that initially we have used the first battery into the first computer, right? And we will leave it for now, right? And then we will after 2 minutes what we will do, we will add another computer, right? We will add a battery in another computer, right? when we are inserting battery 2, right, what we have to do, battery 1 still is running in computer 1, right? And it can still run, right, for 1 minute. By end of the fourth minute, right, similarly we have removed this one, now we have this one, right? So we can use this one for 1 minute, and for next 1 minute this is completed, right? Because after 3 minutes, if we are reducing 1 minute, right, here we are reducing 2 minutes, right? From here, right, 3 minus 2 is what, 1 we have, and for here now it is 1 minute we are covering, right? So now the remaining 1 minute is here is 0, correct? So now what will happen, we are reducing 2 minutes, right? So we can reduce here also and here also, right? So 2 minutes we will cover, right? So after covering the 2 minutes, what will happen, there remain 1 minute and there remain 2 minutes. You can pause and we can think, right? And then after 1 minute what will happen, here is only 1 minute it will run, and it will run 2 minutes, right? So after this is become drained 0, and this is also going to drain after the 1 minute, right? But he can still run 1 minute, right? As you can see. And here we have what, 2 minutes is drained, right? So we can take what, it's only take 1 minute. So after this only one minute can run here only, but the rest of are drained, right? Second battery. And that's, you can see that we have taken 2 minutes, 1 minute and 1 minute, total 4 minutes we have taken. So it will take 4 minutes for this output, okay, to get the output. Similarly, if you will take n equal to 2, means two computer we have these two, and batteries we have given 1 right, means the first time we have these batteries we have given, right. So I'll take the first battery and insert in the first computer, second battery we will take here and we will put here, right. After 1 minute this one is dead and this one is also dead, right. Now we can run 1 minute here and 1 minute here. So after 1 minute again all the batteries are dead, right. So only 2 minutes will take it, right, and that's why it is giving like this. So from the first example, right, let's try another distribution plan, right. We are going to understand. So we will take two battery support, right. Let's suppose we are taking two battery support, two computers we have, and two battery support we have, right. So two computer can run simultaneously. We will end up with the two empty battery and one battery full, okay. So then the running time is fixed at what, 3, correct. So since we can't use the battery left to support computer 2, right, if this is dead, this is also dead, right. So if any other battery is there, that is no meaning, right, because that is already dead, right. So the running time is fixed at 3, because if we are taking any 2 minute, right, let's suppose any 2 minute we are taking, right, two battery we have and we are supporting two battery, right. So whatever the time we have in the first battery, it will take that time, right, and we will end up with the two empty batteries and one full battery, right, because if this will get run, right, so it will get computed, it will get dead, right, and it will still remain, right. So for the next time what will happen, here we have taken 1 minute one battery, here we still remain one battery, okay. So it implies that there is a strategy to distribute the battery properly. So we will see how to do and find the best pattern, right. So in the first approach, what we have sorting and prefix sum, right. This is the approach, sorting and prefix sum. So first we simply original problem a little bit we will do. So let's suppose we have 4 computers, right, A, B, C, D we have, and have to pick exactly 4 batteries. So we have 4 batteries. So what is the maximum running time that we are going to see, right. So this is a quite a straightforward question, right. So we just pick the largest 4 battery, right, and then let them support these 4 computers separately. Let's call the list that contains the 4 batteries is live, right. And the running time is determined by the smallest battery that we are going to pick, right. So smallest battery that we are going to pick. So what if we allocate to 5 to pick a 5 battery, right. So let's pick the largest battery that isn't used, right, isn't in use, right. So clearly the smallest of these 4 battery will be bottleneck. So we use the power in the 5th battery to increase the running time of a computer A, right, that has a smallest battery, right, because A computer have the smallest battery, right. So what will happen if we will mark like this, right. So it will this is we are going to mark like this, right. So upon this is the bottleneck, right, bottleneck you can say. So above this is called extra batteries, sorry. Sorry. So now you can see so what if we allocate a pick more batteries, right. So after that you have seen that this is we are making this as a bottleneck, and this is called extra batteries, right. So we can freely use every battery except the largest 4 to increase the total running time, because we can freely swap batteries in 0 time and all the extra power is interchangeable. So we can take this extra power and transfer it to the battery in the live. Let's understand the extra with the sum of all the power, right. So let's say live is sorted, okay. So after the live is sorted, how it will look like, right. So it will look like this, correct, because this that we have taken the extra we are putting here, right, and if we put this it will look like this one, right. So we can freely use the battery except the largest 4 battery, right, that increases the total running time, because we can freely swap the battery in 0 time, and all the extra power is interchangeable, and we can take this extra power and will transfer to the batteries, right, that is in the live, right. So let's say extra be the sum of all the extra power, right, and that's why we are taking from here, right. So we are saying the live is now sorted by using the sum of extra power to increase the live at 0, right? At here, this is at live at 0, right? And so running time to live, this one also, right? So the process become what? Extra minus equal to live 1 minus live 0, means this one minus this one, that whatever will data will have, that will come this one, means if you represent this one, so extra minus will take as what we can take that live, we have live at 0 minus live at 1, right? Whatever will come, that will do minus here, right? So now let's understand the leave, sorry, this will come 0, this will become 1, and this will become 0. Okay, so now leave 0, that we are talking about this one, and leave 1, right? If it equal to 1, so we can continue by trying increasing the time to the live 2. We will increase the time for this one, right? However, not only would we need to increase live 1 to live 2, right? We also need to increase live 0 to live 2, right? This level we are talking about. Okay, so it's bottleneck. So it does not bottleneck the running time, right? We already spent some power to increase live 0 to live 1, right? That we have already seen here, and then we will increase this one, right? This one, correct? So from live 0 to live 2, so it doesn't have the running time, right? Bottleneck time. So we will already spend some power to increase 0 to live 1, and so we'll do for the live 0, what we will do? Live at the power, right? Live 2 become what? We'll do minus live 1. Whatever will the data here, right? That we will increase, right? Using the minus. So this much we just need to spend twice as much as the power of this one. Whatever will come, that power of twice will do to increase this one, correct? Because it is required here and here. Got it? Means x here, x here. So x is the difference, so we can say 2x, correct? Now, so we need to spend twice as much as the power as the difference, right? So live 2 minus, we'll do live 1. This is 2, this is 1, this is 0, and this is 3. So if we'll do minus between this one, that is called x, and that is x, right? That is your 2x, right? So what will happen? It will look like this one, right? So you can see the extra is now getting reduced, right? So now we have some, let's suppose we have live 0. So at live 0, we have what? Live 1 and minus live 2, correct? So if we want to increase this one, right? If we want to increase the running time to live 3 here, right? So what we have to do? We have to do 3 times. If we will calculate from here to here, the difference is called x to match this one, right? So what will happen? We have to increase for this one x and this one x also. Means 3x time we have to do this time. Previously it was 1x, then 2x, now it is, right? So we are doing that. So what if we have an example where extra is the large amount to support all the battery in the live becoming equal to live n minus 1, right? Whatever we have, if there is n, then we have n minus 1, right? And that is called live of n minus this one, correct? And it is enough battery to support, right? Got it? We have extra is large enough to support all the battery, that is equal to become this one, right? Means like this we are talking about. So any remaining power in the extra should similarly be eventually split across all the computer to increase the final running time. So the final running time is determined by live n minus 1, whatever this position we have, that is called n minus 1, right? So from this battery we'll do plus extra running time that we can make using extra power, which is extra by n, that we can do that this extra by n, right? So it will look like what? This one. Got it? So to generalize this concept, or you can say to understand this concept, at least each battery that live at what, some this one, right? It battery live at this one I, let's suppose this is at I, if this is at I, right? So live at some value, right? If you want to increase the running time, what if it is at live this one, so we can say live I plus 1, we can say, right? So we need to spend I plus 1 time, right? If this is I, so we can say I plus 1 time times as much as the power we have, right? So that we will say live of this one minus live I, correct? Live at I. So with this formula, we don't actually need to update the value to the live, right? Since after each iteration, we already knows that live at 0, if you'll calculate, that will come live 1 to live something, correct? And so, like what I'm trying to say, we are saying live at 0 if equal to live at 1, and so on, it will go to what, live at I, means all become equal, right? So we iterate through live, you can say, until we either cannot afford to increase to live plus 1, right? Live I plus 1. So anymore, or we manage to iterate through the entire array. In both cases, we do our best to eventually allocate the remaining extra power. So you may be thinking that in the case here, since there is some unused power in the large battery, right? So the largest battery on the right, that we can say this one, right here, right? Can we further increase the total running time using the unused power? And the answer is no. So as you can see here in this picture, right? Suppose we do allocate the power equally by using the extra power of the largest battery, that is colored in the red color, as you can see here, right? And so on the other computer, right? It means that there are times when the red battery is used on the other computer, but some battery also support computer D at all times, right? So this contradicts the rule that one battery cannot support more than one computer at a time, at the same time, right? So therefore we observe that if a battery I has more power, right, than the total running time, okay, so there is no way we can use the access the power of further increase. So the running time will increase, right? Therefore we can pick the largest n battery and assign them to n computers. These battery are tried to their computer and swap them to does not bring the longer running time, right? So what we will do here, first of all, we will sort all the batteries, right? This is we have given n computers, we have given, and batteries we have given, right? So what we will do, first of all, we'll sort the batteries, right? And then we'll find the largest n batteries and assign them to n computers. So these n batteries are exclusively used by each computer, right? And cannot be shared by the other computer, right? So to do that, what we have to do, we have to create an array that is called live or something else that we will see, okay, that contains the largest n batteries in the sorted order, right, which represents the n computers, right? So as you can see, we can take an extra, right, and over all batteries, right, from battery's length minus 1, we'll start with that, okay, we'll assign that value, and then we will find our extra plus will come from what, batteries at I. So all batteries will add here, right? How we'll find this one? So battery's length minus n we will do, and that is called extra batteries, right? So we can find from here, and we'll store all the value on the extra. So now you have extra, right? Now we have to create an array that is called live, right? So we are going to create an array live that contains the largest n battery in the sorted order. So how we'll do that? So there is a copy of range, right, where we will pass the battery array, and battery length minus n will find, that is called your sorted, right, and the length, right. So that will come and it will store here all the values. Now what will happen, we will sum up the power of the remaining battery in the extra, right, as extra. And so what we have to do, we will iterate over live from 0 to n minus 1 for each index I, right? So if the power can create so the power can create or you can say increase the running time of the first I computer from live I to I plus 1, right? Then we subtract the required power from extra and move it to the next one, right? So how we'll do that? So we are getting extra power from here, right? As you can see, we'll get extra power from here, and then we will multiply for all those computer, and if it is less than extra, we'll say live plus extra by I plus 1, right, total computer. And that you can do like here also, right? So it will come in the extra only, right? So from live n minus 1 by I will do plus extra by n, and that is called your answer. Because if there is still power left after the iteration, it means we can further increase the total running time of n computers from live n minus 1 by extra by n, right? And that's why from the live n minus 1 and we are doing plus extra by n. So therefore this will return as answer. Okay, I think you got it. Okay, so first what we are doing here, we are doing sorting, right? We will sort the value, then we will find the extra battery, right? After this we will find the you can say we will create a live array, and that live array will contains the largest n batteries in the sorted order. Okay, now what will happen after this, we will calculate you can say the extra, if the extra power can increase, right? If it is increasing, then we'll calculate the extra, right? How? Like this, extra minus I plus 1 into I plus 1 minus I, correct? So this will give you data. Okay, and the final n minus 1 plus extra n by 2. So we are checking if the still power is left after the iteration. If we have, right, for the n computers, right, total running time of n computers, that will come from what? Live n minus 1 and plus extra by n. Okay, so that's all we have for today, right? If you like this video, please hit subscribe this channel. And for time complexity, what will happen, it will, if let's suppose we have we are sorting batteries, right? Here, see here, we are sorting this battery starting, right? So it will take you can say if there is m is a length of the input array, right? Let's suppose, then after sorting this one, it will become m log m times. Okay, because O of n times it will take to pick n batteries, right? And for the space complexity, because we are taking m, so it will take O of m for the space complexity, because we are storing that value on the live, right? So that's all for today. If you like this video, please hit subscribe this channel and stay tuned with Expert Panda.